Hi guys, thanks for tuning in. I showed you on the practical side on my previous channel, but what I've got here is that I've got an example of a gable roof. For example, I've got a rafter, I've got a ridge capping, I've got another rafter. You can see it's at 22.5 degrees, which is what we have, which is what I've been doing on my previous model. I'm just simulating a 22.5 degree roof pitch, double top plates. We've got our stud and we've got our bottom plate. The rafter length is from that point to that point. And then obviously we've got our overhang, which you can nominate 100, which I think I nominated 100 millimeters on my previous model. And then obviously that's the total rafter length from the ridge to that point there. That's obviously plumb, or what we call vertically level. And that's the plumb line as well, which is vertically level. And that was the plumb line as well, which is vertical level. And I showed you last time, we would put our gauge at the top and we would hold it up like that. Just as an example, I've got it here. We would put the gauge up like that and we would hold it like that. We would do the same thing there and we would do the same thing there, and that's how we got our gauge. And remember, our gauge, our vertical is our plumb. So when we're talking plumb, we're talking about being vertically level. What I wanted to bring to your attention was that when we use my little template, for example, this distance from there to there is actually the distance from the external part of the stud wall to the center of the ridge capping. That's all that is. So in other words, that distance is the same as this distance from there to there. So to get the center, obviously we would have the distance from the external part of the wall to the other external part of the wall, whatever that distance is, and we would divide it by 2. That gives us our center. And then I've done the same thing here. And when we've got that distance through there, remember when we go to the center line, I've put these green dashed lines to replicate the thickness. It's actually to simulate the thickness of the ridge capping, or the thickness of the rafter, if you want to think of it like that. And that's 17.5 millimeters on either side, because the thickness of the ridge capping in this instance is 35 millimeters. So 17.5 millimeters. So just as an example, on my model here, my distance was actually 876 millimeters from there to there. So that point from there to there was 876 millimeters. Then I wanted to work out this height here. When we work out this height here, we use my tan formula. I just use my tan formula. Tan formula of tan of 22.5 is equal to the height of this point divided by the base. Now the base in this instance is this distance from there to there. Okay, that's the distance from there to there, and that gave us our height. Now when we get our height, we also have to add this little part here, which is roughly 70 millimeters. So once we've got our height there, we would then add this part here, which is roughly 70 millimeters. That will give us the height from the top of the top plate to the top of the ridge. And as you can see here, I've actually simulated ridge capping installed here. So I worked out that my height from there to there was 435 millimeters. So what I did was I actually got my tape measure and I measured from the top plate to the top, roughly 430 odd millimeters is what it worked out to be. So I was able to actually then use that theory, 435 millimeters, to then prop up this ridge line. And you can see I've actually propped it up with clamps. It's clamped on one side and it's clamped on the other side. So I've already got my height set up, which is this point here. I've already got my ridge height set up. So all I had to do then was to then work out my rafter length using Pythagoras' theorem. So we've got this distance, we've got this distance, and we can use Pythagoras' theorem to get that distance there. And just as an example, what I've got here is an example of it here. So it worked out that our rafter length was actually 0.948 meters, or 948 millimeters. So from this point through to this point, was actually not 948 millimeters, and our overhang was roughly 100 millimeters. And when we allowed for the bird's mouth, obviously there's the bird's mouth cut, and there's the point that we don't want to go over. I then cut this out. I use my gauge as I showed you on our model before, and what we did was we had our point along there, we had our point along there, and of course we had our other points back through there. Okay guys, I then cut this out, and as you can see, I've got it nominated at my ridge height. I placed it along there, and that's pretty much set at that angle. So that's the angle already set for you guys, okay? So I just wanted to demonstrate to you that using this theory here, using this analogy here, does actually help in terms of allocating, or actually nominating a height for the ridge. We actually set it, we clamp it, and we've already got it set in place. So I hope that gives you another perspective of installing a timber rafter or gable roof, and I hope using the theory that I've demonstrated to you helps you that little bit further in terms of installing or having a go at installing timber rafters. Thanks again for tuning into my channels. I hope that was insightful for you, and I look forward to your views, I look forward to your comments, and thanks again for your great support. Bye guys.